I'm Shimpei ONO from Central Research Institute of Electric Power Industry. I would like to present Vibrational Energy Harvester with Electric W Electret. This work is done in collaboration with CREPI and the Purdue University. Recently, energy harvesters have been extensively investigated to realize an alternative energy source to the battery. To achieve trillion sensor universe, there is a strong need for batteryless sensors. For these reasons, we try to convert vibration from infrastructure, human motion, and so on, to the electric energy enough to operate sensors and the signal to the internet. However, if we want to monitor these infrastructures, we need to create electricity from low-frequency vibrations. For example, if you see the vibration of the bridge, the resonance frequency is around 50 Hz, depends on the structure. Also, if you see the trucks, resonance frequency is around 10 Hz. If you want to monitor human body, it is around 4 Hz. So, we need to develop the energy harvester which create energy from low-frequency vibrations. However, it is still difficult to gain energy from low-frequency vibrations less than 100 Hz. If we want to create energy from low-frequency vibrations, there are three ways. One way is using piezoelectric materials. Other is using electrostatic materials. Both ways, we need to use very thin beam and the large mass at the end of the beam to gain energy from low-frequency vibrations. But due to this structure, it is very fragile. The other way is using triboelectric materials, but the large force is necessary to gain enough energy. To overcome these problems, in this work, we concentrated to the electrostatic energy harvester. This is a schematic picture of the electrostatic energy harvester with Electret. If we insert electrode to the Electret, the charges are induced at the electrode with electrostatic effect. And this method is fit to the MEMS technology, and we can design the structure depending on the resonance frequency. However, there are still several spaces to improve these structures. For example, this structure, the gap between the electret and the electrode is air or vacuum. But if we want to enhance the capacitance of this gap, we can expect the total carrier accumulated at the electrode might enhance. To enhance the capacitance, we are going to apply electric doubler of the electrolyte. What is the electric doubler? So we sandwich with electrolyte with two electrodes and apply the voltage. The electric doubler are formed after ion redistribution. When we zoom in the interface between the electrolyte and the electrode, the electric field is confined only to the electric doubler with a thickness around 1 nanometer, depending on the size of the ions. So if we apply 3 volts to the electrolyte, the electric field at the electric doubler becomes as high as 30 megavolt per centimeter. Using this extremely high electric field, high-density carrier up to the 10 to the power of 15 per square centimeter are induced at the surface of the electrode. There are several studies using an electric library to the energy harvester. But this work, they use a mercury droplet. This work is using water as an electrolyte. But since it doesn't use ions, the capacitance of the electric double layer is not so high. So we try to use the ion liquid as an electrolyte. In the beginning, we directly put the ion liquid on top of the silicon electret. But due to the static force, ion immediately attach to the surface of the electret, and we cannot change the surface area efficiently. Then we try to use ion gel instead of the ion liquid. But indeed, we can change the surface area which attach to the surface. But still, we need to use the electret to sustain the electric double layer, or we need to use other power source to sustain this electric double layer. To overcome these problems, we are going to introduce electric double layer electret. So this is a picture of the electric double layer electret. So in this case, we use the ion liquid. Both cation and the anion have an unsaturated bond, and mix with the polymer. And then we sandwich with two electrodes. After we apply the voltage, the electric double layer are formed. And then we shine the UV light to polymerize these materials, and the ion is fixed inside the polymer networks. And so far, more than 99% of ions are fixed inside the polymer networks. This is a picture of our electric double layer electret. So one side is positively charged, and the other side is negatively charged. So it is similar to the permanent magnet. For example, if we try to attach the positively charged side with the positively charged side, there is a strong repulsion. But if we try to attach the positive charged side with negative charged side, it is attaching. So it is similar to the permanent magnet. Using this electret, we are going to fabricate the vibration energy harvester. We sandwich electret with two electrodes, and when we attach and detach the electrode, electrons are induced at the electrode. Since the capacitance of the double layer electret are huge, large current are accumulated at the surface of the electrode. So this is the demonstration of our vibration energy harvester. And here is the electric double layer electret. So some people might ask us, is it a really electrostatic effect? Or it is more to the piezoelectric effect or triboelectric effect. So to prove that there is an effect of the electric double layer, I'm going to show the data. And this way, left-hand side, the cation side is on top. And the right-hand side, the anion side, is on top. And the blue line is the position of the electrode. And here, electrode attached to the electret. So, for example, if you see that when the electrode detach from the electret, and this side, positive charge side, when we detach it, it gives a negative current. However, if it is the anion side, and then it gives a positive sign. So if we flip it, it gives a different sign. This is one proof that depending on the surface of the charge, we got a different sign. Our signal is like this. So in this way, there is no signal. It's a small signal is observed before the electret attached to the electrode. So it proves that when we change the speed, and then this electrostatic effect is going to shrink. So that's why we believe that there's actually electrostatic effect with these materials. Finally, we are going to show the best performance so far. So average peak power is around 90 microwatt, and if we this and it is around 0.5 milliwatt per square centimeter. So it means that if we enhance the size of the electret, we can get more power. Another good part is the output voltage. So output voltage is more than 2 volt. So if we can easily charge. Finally, I would like to summarize this result. So new type of the energy harvester with electric double layer are proposed. So new concept of the electric double layer electret and generate current with the external bias voltage and the large output current as high as 0.15 milliwatt is obtained from low frequency vibrations. Thank you very much for your attention to the capacitance or batteries. Another thing is that this material is air stable because we recently used fluorine terminated ion liquid, and there's a strong repel of the water from the surface of this electret. So when we touch and detach the electrode, the electron is moving and this way and this way, so that LED shine depending on the direction of the electrons.